All right, so we wondered what would happen if we had an exponential power. And so now we have our Fibonacci numbers might be a constant times 1 plus root 5 over 2. Constant 1 plus another to the n power. Jeez. Plus a constant 2 times 1 minus root 5 over 2 to the n. Okay. And we know at the beginning we start at 0 and 1. So when I plug in n equals 0, I get 0 equals a constant. What's the number to the 0th power? Do you know?
It's just 1.
So that just simplifies this constant. What's the number plus constant 2? Also this number to the 0 power.
1.
1. So constant 1 plus constant 2s equals 0. Well, that's pretty easy.
Yeah.
That just means they're opposite of each other. And then for 1, I get 1 equals a constant. What's 1 plus root 5 over 2 to the first power?
It's just 1 plus root 5 over 2.
1 plus root 5 over 2. Plus a constant 2 times 1 minus root 5 over 2.
Now this doesn't make much sense.
How come?
Because if they were opposites of each other, this would still be 0.
Ooh. All right, let's be careful how we're looking at this. It's
Oh,
good,
no,
good instincts.
It's 1 minus root 5 over 2.
Okay, so
they might be different.
I have, first of all, I can multiply everything by 2 here, right? To get rid of the fraction that's on the bottom of everything, and it just changes this size to 2. And now what you notice is I have a constant 1 plus a constant 2 from there, which has to be 0 from the equation above.
Yeah.
But the other one is constant 1 times root 5 minus constant 2 times root 5. Right? So this simplifies to be root 5 times constant 1 minus root 5 times constant 2 equals 2. Okay? And now what I'll do is I'll just divide the root 5 to obtain two equations that look like this. Constant 1 plus constant 2 equals 0, and 2 over root 5 equals constant 1 minus constant 2. Do you know how to solve equations like this?
Oh, you could try to get rid of or you could get rid of constant 2 by adding them.
Okay, if I add them I get 2 constant 1 equals 2 over root 5.
So then constant 1 equals 1 over root 5.
And what does constant 2 equal then?
Negative 1 over root 5.
Very good. So this would tell me that the Fibonacci number n would equal, remember our constant was 1 over root 5.
Yep.
1 over root 5 times 1 plus root 5 over 2 to the n minus 1 over root 5 times 1 minus root 5 over 2 to the n. So we just found what seems to be a fairly complicated formula for the Fibonacci numbers, but nonetheless.
It works.
Well, we haven't checked it yet. It looks like a complicated formula for the Fibonacci numbers, but it's a formula. It's an explicit formula that's not recursive. This is a formula that doesn't depend on the prior numbers.
Yeah.
Okay? So now what we're going to do is we're going to put this formula into Mathematica. And we'll just try it out.
Okay.
Okay?